Hi, this is Team 8 of Kim Hui-won, Lee Nam-hoon, Cho Ah-la, and Justin Chan. For the past 8 weeks up until last week, we have been presenting about the facade of the Haidar Aliyev Center. In order to express the freeform facade, the architects chose to use GFR panels. And the main structure supporting the panel is the space frame. Now, let's take a look inside the building and the structures that support it. This picture is the site plan of the Haidar Aliyev Center. And this is the first floor plan. The Haidar Aliyev Center is split up into 3 major programs. First, the exhibition hall, shown in the highlighted red. Second, the library, shown in the yellow. And third, the auditorium, shown in the green. The 3 spaces are separated from each other and have their own entry and security areas. Under the continuous surface, such as a free-flowing fluid, the building is divided into the 3 separate areas by the curves of the roof. But on this screen, do you find something strange? There is a library requiring a quiet area, but an auditorium is placed next to it. How is this possible? Let's take a deeper look into the auditorium of the Haidar Aliyev Center. The auditorium is a state-of-the-art 1,200-seat venue, one of the biggest in the city of Azerbaijan, and the first in the world to be built just 60 meters away from a library. There's something funny about someone reading a book very quietly, while on the next door there's an opera playing and know what is going on in the other. In order to achieve this, the architects needed to get rid of the sound noise. This process is called sound isolation noise control. To do this, they use a very thick concrete wall so that no sound will pass through the auditorium. In other words, the auditorium is actually a building inside another building. This construction method is called box-in-box construction. Box-in-box construction is usually used as an acoustic isolation technique, especially in cinemas, recording studios, and other instances where near silence is needed. There are 3 main methods. Let me briefly explain the general box-in-box method. First is floating acoustic floors. The new floors will be constructed using concrete and will rest on springs or elastomeric bearings. This means that an air gap of up to 200 millimeters is created between the 2 floors. Second, there are acoustically isolated walls. Using the concrete block and various insulation layers, they float the original wall with thickness. Lastly, there is an acoustic ceiling. The new ceiling typically comprises of acoustic tiles suspended on hangers fixed to the exiting ceiling. Split into flooring and ceiling parts, I'll explain the box-in-box construction in the Haidar Aliyev Center through the section plan. In this building, the concert hall is a contained box separate from the library by 6 soundproof walls made from 60 centimeter thick concrete and a 12,000 square meter layer of rock wool insulation. Inside the box, architects wanted the floor walls and the ceiling wrapped by more than 280 interlocking oak panels. It is only the concert hall in the world to be clad entirely of wood. Flooring construction methods used in this building can be categorized into 3 parts. One is the noise and vibration controlled floor of the stage. Second is the orchestra pit. And lastly, the seating area. To prevent vibration and noise from the stage, a steel platform was installed on the concrete slab. The truss steel frame sits on a 65 millimeter thick flooring screened with a rubber mount. And in between, a 10 millimeter thick sound insulation material made of cork or rubber is inserted. On the very top of it, acoustic underlay and wooden materials which tend to absorb sound rather than reflect covers the structures. All these aspects make the stage more stable and quieter, reducing vibration and noise. This material stack can be seen in the graphic above. To change the conductor's position by adjusting the height, the orchestra pit is a sunken-like form. Then on the ground, an automatic lift system is installed on the platform. Thanks to this, depending on the height of the orchestra pit, the view of the audience and the orchestra members can be secured as needed. Lastly, the seating area. In order to secure the site, the seats are cascaded to be higher in the back of the audience, with cross bracing designed differently for each height being used to make such a shape. Let's move on to the ceiling. The second ceiling is hanging in a ceiling void. It acts as an acoustic barrier separating the room-to-room sound. Under the box-in-box construction of ceiling, the wood panels are suspended by suspension rods from the actual ceiling. Additionally, the auditorium is 18 meters high and spans approximately 28 meters, supported by concrete shear wall around the space. To reach a large span, the outermost layer of ceiling is constructed by a two-way system and adopts the steel space frame. While an all-wood interior creates the sculptural look, it limits sound engineers with a single acoustic environment. It is a challenge since it's a multifunctional venue designed for speeches and live orchestra. Each of those different kinds of performance have different acoustical needs. The bigger the space, the more sound reverberates, creating echoes ideal for music but problematic for speeches. How do they accomplish both seemingly opposing goals in one single space? A concept called coupled spaces was introduced. Designing a coupled space hidden above the ceiling, 4 meters of additional room is used to modulate the reverb. For concerts, retractable wood panels swing open, creating a live room with 1 second of extra reverb for music. And in a speech situation, they're closed, cutting reverb in half and deadening the room. Like this video filmed on the construction site, they operate a movable flat panel in order to connect two spaces to change the volume. The wood panels are hoisted 18 meters by a cable system, and a team of 4 workers are in the coupled space. As they are tightened, the cord gets tense, which means the weight of the wood panel is now being suspended from the ceiling. It takes 24 tension cables to support just a single panel. This is the end of our presentation. Thank you.